Evry Schatzman.
Evry Schatzman is Director of Research at the CNRS in France and is regarded as the father of astrophysics in that country. He is the author of a most extensive body of work ranging from stellar nucleosynthesis to cosmology and of numerous philosophical essays. With the questions where do we come from and where are we going asked of the heavenly bodies, we cannot help feeling philosophical emotion or projecting them onto many other questions concerning the future. Dr. Schatzman is about to publish a very serious, painstaking study of the possibilities of extraterrestrial life. And so his standpoint with regard to the subject of this meeting, he declares himself to be a staunch determinist, is therefore a compulsory point of reference.
Many thanks for this introduction and all my gratitude to the organizers of this meeting for inviting me here. All what I hope is that my contribution may be of any use to the goals of the organizers. I would like to start by a sort of historical view on the universality of the laws of nature. The wolf eats the lamb, and with the lamb makes wolf. The lamb eats grass, and with grass makes lamb. This has been noticed a long time ago, since Democritus and Epicurus. Lucretius says it in the following way: and it is in such a way that nature changes in lively bodies all possible kinds of food. The continuous change of living beings into other living beings with different shapes and properties led the Greek atomists to imagine a common principle, an invisible constituent, which would produce, with different ordering, different living creatures. The atomic theory has no other foundation. This idea that changing a being into another one is possible only because made of the same parts, but otherwise ordered, has crossed the centuries and is the basis of the great recent physical theories. To notice, as it is done every day, by looking at the data provided by the large accelerators, each free particle can, in a proper interaction, generate other particles, led to the idea that a common principle, an invisible constituent, but with different ordering, gives the different free particles. To give such a statement, it was only necessary to replace living bodies by free particles. In order to extend the analogy, it would simply be necessary to replace atomic theory by grand unification. Even if the comparison is not valid, the parable of the wolf, the lamb, and the grass speaks in favor of the wonderful power of reasoning of the Greek atomists. The ability of nature to generate species and therefore to produce large numbers of the same beings is immediately generalized by Lucretius. The same principle convinces us that the sky and the earth, the sun and the moon, and everything alive are not unique and contrarily exists in infinite number. This generalization has reached us. A modern statement would be to speak of a principle of universality of the laws of nature, with a difference, that instead of being a speculation, It rests on a large set of observational data. The system of the Greek atomists, with its plurality of worlds, has been occulted for a long time by the Aristotle system, more complete and consistent. The Aristotle theory of motion, its discrimination between the perfect circular motion and the imperfect fall of heavy bodies, led to the rejection of the existence of other worlds. But another reasoning of a non-rational nature brought back the idea of plurality of worlds. The belief in Almighty God led to imagine the creation of other worlds. In 1277, Etienne Temper, Bishop of Paris, condemned 219 beliefs currently spread in the universities, which he considered as heretics, as limiting the power of God. Among these beliefs was the one according to which the prime cause could not make several worlds. Following the condemnation, the critics of Aristotle grew. Occam said, "I state that God could create another world better than ours and distinct in nature." Orem asserted the existence of extraterrestrial matter, opening the way to a new look at the universe. Giordano Bruno, in La Cena della Ceneri, declares that the world is infinite, and the Italian dialogue dell'infinito universo mondi defends the new gospel of the unity and the infinity of the universe. If in our domain of the infinite space there is a world, a sun-star with planets, the same exists everywhere in the universe. With his refractor, discovering that the Milky Way was made of stars, Galileo rejected the idea of a center of the universe and declared that the stars are other suns so far away that we can see them just as bright points. The place of the sun in the galaxy, the nature of the sun among other stars, became known only at the beginning of the century. Shapley, 1921, could show, by studying the space distribution of globular clusters, that the sun is very far away from the center of the Milky Way. The discovery by Hertzsprung and Russell at the beginning of the century of the major properties of the stars showed immediately that the sun is a faint star among many other faint stars. Lambert at the 18th century, Charlier at the 20th century, imagine a hierarchy of systems leading to a complete disappearance of a privileged center. The disparition of a privileged center is achieved with the gravitational theory of Einstein, which states the question of an absolute frame of reference in a new way. It is the whole universe which is the absolute frame of reference, the most obvious absolute frame being the black body background radiation discovered by Penzias and Wilson in 1965. In this absolute frame of reference, our galaxy is a galaxy among billions of others without any special place nor characteristics. Let us get now into more details about the idea of a universality of the laws of nature. The word logos was already used by Lucretius, inspired by the orderly motions of the heavenly bodies. But the exact meaning of the word is not quite the same as 20 centuries ago. As soon as a theory explains a fact in a rational way, it looks quite natural, everything being otherwise equal, to consider it as universally valid. For Lucretius, just as letters of the alphabet can be combined to give an infinite number of words with different meanings, the atoms can be linked to each other in an infinite number of ways to generate the objects and the creatures which surround us. This statement does not seem to meet any contradiction, and therefore its universal validity seems to be established. We cannot be satisfied nowadays by pure logic for delivering such a statement, but the way in which we proceed in order to extend the validity of a law is finally not so much different. The discovery of a universal law is first the consequence of an experimental fact. The discovery by Galileo of the satellites of Jupiter had a very strong impact. It showed that the planets can revolve around the sun, just as Io, Ganymede, Japhet, and Europa revolve around Jupiter. The discovery by Kepler that the planets move around the sun along ellipses, of which the sun is one focus, led to the following conclusion. The same effects being due to the same causes, there is a prime cause which explains the motion of the planets. This prime cause has been stated by Newton. It is the universal law of gravitation. This is the first law, the validity of which goes beyond the human experience on Earth. It governs as well the motion of the moon around the Earth than the motion of the planets around the sun. Observation revealed that there are in the sky thousands and millions of binary systems in which each star, following Kepler's law of motion, moves along an ellipse, the focus being at the center of gravity. The motion of Uranus did show a strange behavior which could not be explained by the attraction of the planets known at the beginning of the 19th century. When Uranus was supposed to be in conjunction with an unknown body of the solar system, the perturbation had to reach a maximum. Independently, Adams and Le Verrier tried to determine the mass and the orbit of the unknown body. With a few assumptions on the orbit of the unknown body, assuming especially that the dimension of the orbit was given by the Bode-Tisius law, Le Verrier computed a very good apparent trajectory of Neptune on the celestial sphere, which led to its immediate discovery by Gall. The discovery of Neptune produced a wave of enthusiasm. The universal law of gravitation had suddenly a new status. Not only did it explain the motion of the known planets, but the discovery of a new planet meant that it was actually a representation of reality. The motion of Mercury, known with a great precision, did worry Le Verrier very much starting 1855. The great axis of the orbit of Mercury rotates around the Sun with a residual amount unexplained by Leverrier of 43 arcseconds per century. It was not possible until the new theory of gravitation of Einstein to explain this motion. Differing very little from the Newtonian theory at the scale of the solar system, the Einsteinian theory becomes very important in the case of very dense bodies, of fast-moving bodies, or at the scale of the universe. In some sense, we can say that it is more universal than the Newtonian law of gravitation, and after years of discussion, it turned out to be the only valid theory which could explain the motion of the binary pulsar. Two stars, very close to each other, one of them being a strong emitter of radio pulses, orbiting around each other, show a number of anomalies in their motion which fit wonderfully into the Einsteinian laws of motion in a strong gravitational field. Changing subjects, I would like to speak about the nature of stars. Putting the Sun at the center, Copernic had well understood that the orbital motion of the Earth should produce an apparent displacement of the stars on the starry sky with respect to an earthly frame of reference. The absence of any observable displacement led to the idea that the stars were very far away. In fact, the first measurement took place in 1831, that is to say, almost 3 centuries after Copernic. The discussion about the finite or infinite nature of the world was leaving the fields of pure logic or metaphysics to enter into the scientific field. Let us recall that for Epicurus or Lucretius, the world is infinite. But this is the logical consequence of a principle according to which vacuum follows fullness, fullness follows vacuum, alternately up to infinity. Launching the stars far away did not change qualitatively the question of finiteness or infiniteness. It changed it only quantitatively. But it changed completely the nature of the stars. From small lights hanging at the celestial sphere, they became bright and burning objects which looked very faint due to their large distances. Nothing can be opposed to the existence of an infinite number of worlds, did say Epicurus. As soon as the stars are far away, this principle becomes reality. The existence of a very large number of stars looking like the Sun gives reality to the universality principle of Lucretius, and this can clearly be seen if we consider the physics of the stars and notice the importance of universal laws of physics. Kirchhoff discovered in 1859 that each chemical element is characterized by the spectral lines which it can emit and can absorb the same spectral lines. The discovery of Kirchhoff had immediately important astrophysical consequences. Huygens and Secchi in 1864, observing visually with a spectroscope established the presence of a few chemical elements in stars and nebulae. The discovery of Huggins and Secchi was very important. It showed the unity of chemical composition of the universe. It showed that the same microscopic processes which are responsible on Earth of the formation of radiation are at work in the sun and stars. Many years were needed to decipher the message of stars and understand that the same chemical elements and the same molecules exist everywhere. All elements found in stellar spectra are present on Earth, but due to the physics of light emission, all chemical elements are not found in stellar spectra. The presence of the same chemical elements everywhere is also the signature of the universality principle of Lucretius. It carries also another message. The production of spectral lines involves a number of laws which imply several microscopic constants. The electric charges and the masses of the electron and the proton, and the Planck constant which enters into all quantized phenomena. The presence of the same spectral lines, even in the most remote objects, shows that these constants have the same value everywhere in the universe. The same physical processes generate everywhere the same spectra. We can say that the quantitative proof of the universality of the laws of nature reaches the horizon of the observable universe. Turning to galaxies, observation shows the existence of a very large number of galaxies. Presently, with the instruments available, it would be possible in principle to observe 2,000 billions of galaxies. The Space Telescope will give access to about 500 times more galaxies. It is clear that completeness is possible only in a very narrow region of the sky in selected areas. For bright stars and close-by galaxies, details of structure are visible. Observation shows that there is no identical pair of galaxies, but that there are similar shapes. The morphological study of galaxies is at the origin of a classification, the most well-known shape being the spiral. It is currently believed that the same physics governs the appearance of these shapes, essentially gravitation and the Newtonian laws of motion. More obviously than the formation of spectral lines, the morphology of galaxies sheds light on the unity of the universe, on the universality of physical processes, because shapes can be recognized and classified on photographs with any other instrument, just with the eye and the brain. Coming back to the stars, it was not until the discovery by Einstein of the famous relation E equal mc squared between mass and energy that the long lifetime of the sun could be understood. Harkins and Wilson, Eddington, Jean Perrin suggested that the solar energy was extracted from the conversion of hydrogen into helium. A better knowledge of nuclear reactions and nuclear cross-sections It was necessary to understand better the energy sources of the sun. In 1938, simultaneously, Weizsäcker and Bethe found the cycle of nuclear reactions which provides the energy radiated away by the stars. Access to the interior of the sun, and soon access to the interior of stars, is very recent. With the suggestion made by Fowler in 1967 that solar neutrinos could be detected, a large underground experiment has been carried by Davis in South Dakota for almost 20 years. The results of the experiment are still under discussion, but there is no doubt that it gives an information on what is going on in the solar core. On the other hand, the very precise measurements of the periods of the different modes of oscillations of the sun gives a direct access to the internal distribution of temperature and density inside the sun. Observations of the oscillations of the components of the binary star Alpha Centauri raise new problems. Planned observations of stellar oscillations from space will provide, in the near future, the same kind of information on the internal structure of the stars. The same comment can be made about the internal structure of the stars which we have made before. The same microscopic processes take place in all stars and provide the basic explanation of their gross properties. But the analysis of the observational data by the theory of the internal structure provides another important information: the chemical composition inside the stars. Despite a number of difficulties of the theory, the main result is that all stars have basically the same abundance in light elements. In the case of our galaxy, the general picture is the following. The galaxy has an history. Its chemical composition has changed since its formation, and comparing young stars and old stars, it seems possible to have a knowledge of the primordial chemical composition of the galaxy, which is about 3/4 of hydrogen and 1/4 of helium in mass, and a very low abundance of other elements. It seems established that within the errors of measurements and theory, other galaxies have the same primordial composition, the results being derived this time from the spectral lines emitted by the interstellar matter. I shall come back a bit later about this problem of the apparent uniformity of chemical composition of the universe, but before going into the field of cosmology, I would like to stop a minute and drive on a few conclusions from what I have said. We have noticed that there are different levels of organization of the matter, and this goes from subnuclear structure to nuclei, from nuclei to atoms, atoms to molecules, molecules to life, and then, if you wish, to intelligent beings and society. Another kind of organization is the gathering of atoms to build planets, stars, galaxies, clusters of galaxies. There is absolutely nothing original in these statements. The 18th and the 19th century have enlarged considerably the realm of physics. More and more phenomena and processes did find a rational explanation. Determinism, in the Laplacian meaning of the word, seemed to be valid everywhere. The mechanistic view of the world spread and dominated, and without getting into the content of a very well-known master work, the title of the book of La Métrie, L'Homme-Machine, the Machine Man, give an idea of the kind of representations which was present among learned people, scholars, and the well-educated people. It is quite clear that the conception of a determined man stemmed from an extrapolation from celestial mechanics and from the incredible ingenuity of the 18th century automats to the real man. It is not surprising that there appeared to be a conflict between the consciousness of free will and the theory of a determined mind. This seems to be nowadays a little bit obsolete with the new developments of neurophysiology and with the growing understanding of the brain. But it takes so much time to go from the discoveries to their acquaintance and their understanding by the people, that we are still speaking about the relief which has been brought by the description of quantum mechanics 50 years ago. The free will of the electrons was a relief. If the electron is free, then man is also free. I do not think that there is any real contradiction between the kind of determinism which can be induced by the physicist's work and the philosophical concept of human free will. Furthermore, the word freedom carries a fantastic amount of emotional meaning in a world where the question of freedom in a free society has become a major political issue. Now a few words on cosmology. The world literature is so rich on the question of the expanding universe that it does not seem necessary to give many details about it. As it is well known, the major observational fact is the redshift of spectral lines. The fact that the spectra of hydrogen at 21 centimeter, that the spectral line of hydrogen at 21 centimeter shows the same redshift than the lines in the visible with a frequency range of almost 6 decades has ruled out, for the time being, all explanations except the Doppler effect. The expansion of the universe is the natural explanation of the redshifts. but the physics of the expansion is closely related to the theory of gravitation. Gravitation ignores screening and is acting at very large distances. Nothing can act against this attraction. And if we imagine an infinite medium without pressure and at rest, it can only collapse. The remarkable property of the Newtonian attraction has been found almost a century ago by Newman and Seliger. It is the basis of Newtonian cosmology. The Einsteinian theory of gravitation confirms the results of the Newtonian theory. Nothing can prevent collapse or expansion. It should be noticed that the expansion of a uniform, homogeneous, isotropic, pressure-free universe is not a consequence of general relativity. It is a consequence of the properties of gravitation. In 1965, Penzias and Wilson, observing radio emission from the sky at 7 centimeters wavelength, discovered the presence of the radiation coming equally from all directions. This discovery has been confirmed by measurements in other wavelengths. This radiation has a remarkable property, which is the following. It is a black body radiation. It is now possible to summarize briefly the situation and to come to the important questions. First, the average number of photons per unit volume is very large compared to the average number of baryons, protons or neutrons, per unit volume. The ratio is of the order of 1 to 10 billions to 1. That is to say, about 1 to 10 billion photons per hydrogen atom. If we consider, second, if we consider the universe, looking at it backwards, we find a situation where galaxies could not have been independent objects. There must have been a gas filling the universe, and the galaxies must be born from this gas. The temperature was higher in the past, and at an earlier time, the gas was completely ionized and opaque to radiation. The transition from the opaque medium to the transparent medium set free the radiation, which after that, traveling billions of years in the universe, has given the black body background radiation. Much earlier, the temperature was high enough to produce a synthesis of light elements out of a mixture of protons, neutrons, electrons, and neutrinos. The major result is that the abundance ratio of helium to hydrogen is not very sensitive to the parameters describing the universe, and the ratio is close to the observed one, that is to say 3 atoms of hydrogen to 1/4 of helium. 3. The remarkable isotropy of the background radiation, after subtracting the motion of the solar system with respect to the radiation field, shows that at the time of decoupling between matter and radiation, the same physical conditions were present everywhere. But at the time of decoupling, the causally linked regions were small, corresponding to the mass of a small cluster of galaxies. The difference between the size of the causally linked regions and the present size of the universe is even more striking if we look at nucleosynthesis. The causally linked regions at the time of nucleosynthesis have a mass of the order of 1/100th of a solar mass. We have then to face the following question. How did it happen that a universe apparently made of non-causally linked regions looks so uniform, homogeneous, and isotropic? 4. If we look backwards again, we meet increasing temperatures up to the point where there is an equilibrium between radiation and baryons. The situation, as noticed immediately after the discovery of the black body background radiation, is that the number of baryons and anti-baryons became of the same order of magnitude as the number of photons. The universe is locally made of matter, and locally means at least hundreds of millions of light years. Is this a purely local effect? Is the universe made only of matter? In any case, if we consider now the physical processes during expansion and cooling, we are obliged to explain, it is compulsory, I would even say, to explain how the baryon to photon ratio has decreased from about 1 to about 10 minus 10. The lapse of time during which the transition has taken place corresponds to an energy range from about 1 giga electron volt to 1 million electron volt. Particle physics at these energies is well known and well understood, and it does not seem possible to find the origin of a departure from complete annihilation at this epoch. This departure from complete symmetry between matter and antimatter, called symmetry breaking, is necessary. We do not know whether the symmetry breaking has taken place in the same way in the whole universe, with the same sign everywhere, or if there has been domains of annihilation with opposite sign, in which case there would be in the universe domains of matter and domains of antimatter. 5. There is a characteristic density of the universe which has the following property called critical. If the density of the universe is larger than the critical density, the gravitational attraction will ultimately take over the expansion and the universe will collapse. If the density of the universe is smaller than the critical density, the expansion will keep going on and the density will vanish in the future. The present value of the critical density is of the order of 2 hydrogen atoms per cubic meter. There is a lot of controversy about the visible mass, but there is no doubt that the visible mass, the mass which emits light, is 3 to 10 times smaller than the critical density. The critical density is time dependent. When we go backwards, the density is higher and higher and differ less and less from the critical density. At the time of decoupling, epoch of production of the black body background radiation, the density differed from the critical density by only 0.07%. At the time of nucleosynthesis, it differed only by 2 × 10^-10. And at the time of thermodynamic equilibrium between matter and antimatter, it differed only by 2 × 10^-13. At what we could call, quotation mark, the beginning of the expansion, it differed from 1 only by 10^-60. 6. What is called beginning here is related to the epoch where the Einsteinian theory of gravitation becomes invalid because quantum gravity turns out to be important. There is presently no consensus on a quantum theory of gravity. However, it is possible to give an order of magnitude of the epoch after which quantum gravity became unimportant. It is 10^-43 seconds and called Planck time. In fact, the theory fails already before that time, and in the energy range 10 to the 16 JeV to 10 to the 2nd GeV, we can say that physicists are just exploring the problem. To summarize, we have to face the fact that at our macroscopic scale, the laws of nature have a universal validity, but that the universe presents a number of properties which deserves a careful attention. 1. The universe is essentially homogeneous and isotropic, but the scale of the causally linked regions has been too small in the past to explain homogeneity and isotropy. 2nd, the universe is made of matter, at least locally, but the large ratio of the number of photons to the number of baryons requires a baryonic symmetry breaking. 3. The universe has not presently the critical density, but has been in the past very close to the critical density. The relative difference was very small, and there is no explanation of the small initial difference. If the density is exactly the critical density, it remains always the critical density. This corresponds to a flat universe. These 3 questions, causality, symmetry breaking, flatness, are really at the heart of the present cosmological problems. Quantum gravity is there, behind the stage, so to say, with only guesses about the very early universe. However, is this the last word in cosmology? Physicists try to answer the 3 questions and seem to be satisfied with a model which fulfills causality with annually fast expansion, provides the proper symmetry breaking, requires flatness. But I would like just to mention that there are other possibilities. And I'm not going to describe these other possibilities and would like just to conclude that from the astrophysicist's point of view, the universal laws of nature act in a completely deterministic way. Naturally, this doesn't exclude hydrodynamical chaos, which has been mentioned, and difficulties like the meteorological predictions. It seems to me that there is no other possible approach of the questions raised by the incredible variety of observed facts. A new physics has probably to be introduced if we wish to understand the questions of causality, symmetry breaking, flatness, and eventually the question of the cosmological constant. It is likely that this will come through the conjunction of macroscopic and microscopic physics. Epistemology will have to follow the results of the scientific quest. But I would like to end with a warning about the fact that there has always been a great temptation to extend the laws which apply to a given level of organization of the matter to another level, and even to jump above several levels and to go from the atom to man and society. And I would like to close this talk by this warning. Thank you.